Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Calculus Grade 12 first principle derivatives. So with that, let's get started. All right, so here I have the title written down. What we're using is the first person derivatives, okay, for our calculus. This is Calculus Grade 12, okay? The derivative basically just means you are looking for the slope, okay, of this line. So let's try one question here. It says calculate the derivative of g of x equals 2x minus 3. And it says from first principles, okay? So the first principle basically means the actual derivative that you're finding, okay, is from the principle of using the x plus h, okay? So let's write down. So say this is g of x. We're looking for the g prime of x. And when you write g prime of x, that means you're basically finding the slope. So the limit as h is approaching 0. Okay? And what we're using is the g of x. So we're going to put g x plus h minus the g of x. And then the whole thing is going to be over h. So just like this. Okay? This is the actual definition of the derivative. Okay? And where the derivative actually comes from. And there's also a shorthand way of finding the derivative as well. Okay, today's class is just going to be us using the first principle method. Okay, so what you're going to do here, okay, is we are going to substitute the g of x. So let's write it one more time. We'll write g prime of x equals to the limit as h approaches 0. Okay, so the first time into this equation, you're going to substitute x plus h, okay? So I think we'll just use like the square brackets here. So instead of x, I'm writing x plus h minus 3, okay? Second time, you're subtracting g of x, so minus bracket 2x minus 3. And you can see it's very effective when you're using the square brackets here. Don't forget that the whole thing, okay, has to be over h. So this is what the equation looks like so far. Okay, also remember, okay, that you do have to write the limit as h approaches 0 all the way down, okay, until you actually are taking the h value and actually substituting 0. So what we're going to do is open up the brackets here. So we're doing 2 times x. Let's just keep it out. So 2x. Then you're doing 2 times h, which is plus 2h. Okay, minus 3. And we are also distributing this negative sign. So you're doing negative 1 times 2, negative 2x. And you're doing negative 1 times negative 3. So it's going to be positive 3. Okay, so just like this. Maybe put the brackets here, okay, so you can see it. And again, the whole thing is going to be over h. Remember when you're using the first principle derivatives, okay, after you do expand and not simplify, but actually just expand the numerator, I notice when I'm simplifying, stuff cancels out. So the 2x plus 2x minus 2x, and it's gone. Okay, here I have minus 3 plus 3, and it's gone. Okay, so what you're actually left with in this case, the limit as h approaches 0, and it's 2h over h. Okay, and in this case, I basically see that the h's are going to cancel each other out, and the limit as h approaches 0 is going to be equal to 2. Okay, does everyone see how to do that? So this is a really simple example because g of x was equal to 2x minus 3. Okay, so I can see this question was very simple. Remember, you can also use it with quadratics as well. Okay, so let's try one example. Let's try using a quadratic here, okay? So let's still keep it as g of x. Let's do g of x equals, how about 2x squared plus, let's do 5x. Okay, so I want it to be something different here. Okay, so we're going to use again the same principle right here. Okay, you can do as many steps as you like. Okay, I'm going to write out my equation. So we're going to do g x plus h minus the g of x. And then the whole thing is going to be divided by h. All right. So again, what you're doing here, okay, is I'm just going to move it over a little bit. So g prime of x, okay, you're doing the limit as h is approaching to 0. So the first time when you're subbing it in here, let's use again our square brackets. 2, okay, x squared. So instead of the x, we're writing x plus h squared plus 5 times x plus h. Okay, close the bracket there. Minus, it says g of x. So you're basically subtracting this, but I want to put it inside the brackets. Okay, so I have 2x squared plus 5x. Okay, close the square bracket. Okay, and the whole thing is over h. Does everyone see how to do that? So the first time when you sub this in, the g of x plus h, for both of these x's, you see that we're subbing in x plus h. Okay? Then when it says minus g of x, you are just subtracting this original equation. I don't need to change anything here. Okay, so everyone is good so far? So one more time, the limit as h is approaching 0. Okay? So remember when you have x plus h, I'm going to write it just on top here. It's basically x plus h times x plus h. So 2. And remember, you're foiling this out, okay? So I have x squared, okay? Then there's x times h, so xh. X times h again, xh, so plus 2xh, okay? The last term is h times h, so this is going to be h squared. Okay, we're going to go to the next term here. We're opening up the 5 and the x plus h, so 5 times x plus 5x. And then you're doing 5 times h, so plus 5h. Okay, so what we expanded out here is just this first part, okay? And then you're going to expand out this negative sign as well. So this becomes negative 1 times 2, negative 2x squared. This is negative 1 times 5, so negative 5x. Okay, and now you can close the brackets here. Okay, and one more time, I'm just going to put the whole thing here over h, okay? And I think if we do maybe one more step here, I think that should be enough, okay? So the limit as h approaches 0. Remember, you could do as many steps as you like, okay? We just have to make sure we're getting the correct answer here, okay? So let's write out our last step here. What we're going to do here is just open up the brackets. I'm going to put arrows so everyone can see this, okay? What we're doing is opening up the brackets, multiply everything by 2. So 2 times x squared, 2x squared. Okay, then you're doing 2 times 2xh, so plus 4xh. And then 2 times h squared, so plus 2h squared. Okay? And I want to just keep all of this other stuff the same. So plus 5x plus 5h minus 2x squared minus 5x. Okay, please make sure you're taking your time, okay, as you're expanding and simplifying this expression. And then let's put the whole thing over h. Okay, now if you notice, if nothing cancels out after you actually simplify the numerator, you probably did something wrong, okay? But I can see a bunch of stuff canceling out. I have positive 2x squared, negative 2x squared. It's gone, okay? Positive 5x, negative 5x, and it's gone. I always make sure I cancel it out, okay? So I'm not rewriting it or anything like that. Okay, so what we'll do is maybe just write it on this side here. Okay, I'm just going to put equals. So the limit, h approaches 0. What we are left with is 4xh plus 2h squared plus 5h, 5h, like this. And the whole thing is going to be over h. I do actually write out one more step here, okay? Just because I can see very clearly where the h is canceling out. So let's do the limit as h approaches 0. Okay, so what you're doing here is 4xh, okay? And we're dividing it by h here. So this cancels out. Does everyone see that? I'm left with 4x. Then this is 2h squared over h. So the h cancels out with just one of the h's. So plus 2h, like that. This is 5h divided by h. So h and the h cancels. And I'm left with plus 5, okay? So the h actually is divided for each of the terms like separately here. So this is what we are left with, okay, in terms of our expression, okay? And now you see basically that I have the h approaching 0, okay? So now we don't need to write the limit as h approaches 0. We're just going to substitute it in. So 4x plus 2 times 0 plus 5, okay? So I notice the 2 times 0 is equal to 0. So what we're left with is going to be 4x plus 5. Okay, does everyone see that? And this is basically what the slope is, okay? The slope of this expression right here, the 2x squared plus 5x, is going to be 4x plus 5. Okay, and this is the method of using the first principles to find the actual derivative, okay? So I think what we need to just remember here, okay, is the actual like formula or the expression. So the same thing, if it was just f of x equals 2x minus 3, this would just be f prime of x, okay? The first time you're always substituting x plus h into the original expression, and then minus the original expression, which is the g of x in this case, okay? And again, every time you expand out the numerator, okay, a bunch of stuff should be canceling out at the top as well. Okay, don't worry about how the expression looks. The expression can be as complicated as you want, okay? When you use the first principle derivatives here, okay, you have to just like substitute into the expression and then expand it out, okay? And here when you're using, this is a quadratic expression, so make sure you are foiling out, okay, this expression here to see what cancels out. All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I'll see everyone in the next video. Thanks, bye.